Hi and welcome to this tutorial on classification. In the previous tutorial, we learnt about oxidation and reduction, and we learnt about assigning the rules for those as well. And we now know how to combine half equations to make a redox equation. So here we are mainly looking at the periodic table, just increasing our confidence, what's where, how can we find things and what do they mean. So we're going to have a look at what periods are, groups are, and the relevance of the proton number too. So here I've got a periodic table, and we refer to a period. When we say that, we mean the horizontal row in a periodic table. That is one period. So period 1, 2, 3, 4, 5. You can see these numbers down here. So elements in the same period or the same row have the same number of electron shells. Then we have our groups. So these are the vertical columns, group 1, group 2, and I'm sure you come across these before. So they are the vertical columns, and the elements in the same group have the same number of outer electrons, and therefore they've got similar chemical properties. And that's where you get asked to identify lots and lots of patterns. So the number of the group that element is found in tells you the number of the outermost electrons. So group 1's got 1 electron, group 2's got 2 electrons, group 3's got 3 electrons, etc. So remember, elements in group 0 over here, they've got a full outer shell. You can see in this particular periodic table that sometimes people like to refer to them as group 1, group 2, and then group 3, 4, 5 in the D block. And so group 3 becomes group 13. That's not how your periodic table is necessarily going to look in your exam, and it's fine to just be like group 1, group 2, group 3, group 4, and pretty much refer to these transition elements in the particular topics that you need to refer to them in. And the number on the period tells you, of the element, tells you the number of electron shells, of course, that the atom's got. So period 1, they've got 1 electron shell, period 2, 2, 3, 3. And the group number is going to tell you the number of the outermost electrons. So there's a real reason for why you've got your elements in particular places in the periodic table. Then, of course, you've got the proton number or the atomic number. That's how we officially refer to it as. And that's going to determine the position. So it's going to be in a particular group and a particular row, but where within that is it going to fall is your proton number. Reminder of some of the calculations that we've used before, we can get the mass number, and the mass number is the dense nucleus. What is the mass relative to 1/12 of an atom of carbon-12? It is the number of protons, or the proton number, plus the number of neutrons. Then we've got the atomic number, and that's just the number of protons. We've got the number of neutrons. How do we work that out? We're going to take the mass number and we're going to subtract the protons from that, and that will leave us with the neutron number. So mass number minus atomic number. Then we have the number of electrons as well. So that's going to be equal to the number of protons. Because if I've got 3 positive charges, I'm going to have 3 negative electrons to neutralize that in an atom. Remember, an element's chemical properties are defined by its electronic structure. So the position of an element within the periodic table tells us a lot about its electronic structure. So the D block elements have an outer shell configuration between a full S shell, a full P shell, and then often they are going to have their D shell. So this is going to be full, this is going to be full. It's their D shell that is incomplete. So it'll be from D1 to D10. So earlier on, we learnt about our periodic table being split into blocks. We had the S block, the D block, and the P block. We also have an F block as well, but we're not showing that on this particular image. So this, of course, corresponds to the subshells. So jump back to our electronic configuration tutorials if you want a reminder of our subshells. And the figure is going to allow us to identify which element is found in which block of the periodic table. And it's going to tell us that if we're in the P block, that these are going to be, the outermost electrons will be in the P subshell. It also summarizes which electrons are going to go into which subshells as well. And we've got our S block, so group 1 and group 2, and they've got an outer configuration of S1 or S2. So their outermost electrons are going to be in the S subshell. Those electrons are going to be lost very easily to form positive ions, and therefore S block elements are going to be really reactive. They also conduct electricity via their delocalized electrons too. Then we've got our D block elements. Now these are going to have an outer shell configuration between S2, P6, and 3D1 to 3D10. So we're going to be filling in the electrons within here in the D block. And the transition metals are going to lose their electrons from both the S and the D. If you remember, the 4s subshell fills before the 3D, but we lose that electron from the 4s before we lose it from the 3D. So jump back a few tutorials to remind yourself if you need to. And they're going to form positive ions and in metallic structures. And then we have our p block elements. So their outer shell configurations are going to be in the p subshell, so between S2p1 and S2p6. And they're going to have 5, 6, or 7 electrons in their outermost shell. So they're going to gain electrons. It's much easier for them to gain a few more to get a full outer shell than it is to lose 5, 6, or 7. So they're going to gain electrons, and they're also going to be able to form covalent bonds too. Then we've got our noble gases, so elements in group 0, sometimes called group 8 or group 18. They're going to have a complete outer shell of electrons. They're usually inert and unreactive because they've already got their outer shell of electrons full. You can see in the image above that there is also an F block, okay, which would be inserted between barium and Rutherfordium. Always struggle to say that word. The outermost electrons in this group are going to fill the F subshell, but you don't really need to know a lot more than that for A-level.